In this video, I'm going to walk you guys through my build of the Fallout-inspired 3D printer, the Vault-Tec Personal Fabricator. This thing has been a massive undertaking. It's been a really fun journey, and I've learned so much, and I can't wait to tell you all about it. Let's get started. How's it going, guys? Angus here from Maker's Muse. As many of you know, I took a break in October to go back to my design roots and learn new things and try new stuff. And although I did post a few necessary videos during that time, I've been mostly radio silent. And one of the things I was working on was this. Many of you might not know this, but when I did my industrial design degree back in, I think it was 2012 was my last year, I actually built a 3D printer which was inspired around cake icing. So this isn't my first rodeo in building a 3D printer, but I've always wondered, like in the Fallout universe, is there a place for additive manufacturing? And I think there is. I think the idea of a 3D printer in vaults fits into the lore quite nicely. If you're not familiar with Fallout, basically, it's a post-apocalyptic world, so the world fell to consumerism and basically turned into a nuclear wasteland with mutually assured destruction, but some people sought shelter in vaults owned by Vault-Tec. It's a little bit more sinister than just protection though, but the idea that you're in a vault and you don't have access to spare parts and tools and things, I do think that there would have been room for some sort of additive manufacturing fabricator sort of thing, which was my inspiration for the Vault-Tec Personal Fabricator. Also, it was a challenge. I wanted to see if I could build a 3D printer within this tiny enclosure. Like, this is it. Like, it has nothing external to it except the filament. It is this small, and it was a huge undertaking to make a 3D printer from scratch to fit inside this. All it needs is the external power connector and the filament. Everything else, including the electronics, is self-contained. That was a crazy challenge. Also, guys, if you haven't seen the unveiling video of this machine, go watch it here, please. I put a lot of effort into it. I had a ton of fun editing it. I made music for it. I put on an act. I did a little sort of intro scene to introduce this as if it was part of the game. It was really fun to do. It's a very short video, so go watch that if you want to see the actual lore-friendly video. But this is all about how I actually made the thing in the real world, I suppose. So let's start with the actual base of the printer. This is actually a promotional item. When I bought Fallout 4, it came with this Pip-Boy and the box. So that actually says Pip-Boy here. The Vault-Tec sticker I did there, Personal Fabricator, just fell off. So I'm just going to leave it saying Pip-Boy. But basically, this is a promotional item that I got with my copy of Fallout 4. And I've actually done videos on ripping files from Fallout 4 and 3D printing them, so I thought it was quite interesting to actually sort of see, can I make a 3D printer that's inspired by Fallout 4 instead of 3D printing things inspired by Fallout 4? So walking you guys through the specs of the Vault-Tec Personal Fabricator, the print volume is tiny. As you can imagine, something this small, you don't have much room, so it's actually only 90 by 120, maybe by about 90 millimeters. That's all you really get, which isn't too unreasonable, but in terms of printing useful things, yeah, you're gonna only get away with just a few sort of small things and nothing massive. But to get it fitting into this volume, there wasn't really much room to make anything bigger. It has a non-heated bed and is PLA only, and that's kind of important because the whole thing is made out of PLA. The whole machine, all the frame parts are PLA, and that's because it's easy to print, it's dimensionally stable, but it doesn't really have a good temperature resistance. So if I had a heated bed in here, especially if it was closed, then the whole thing would melt and deform. So strictly PLA only, using a Bowden style extruder, which is fed through from the back. And the hot end is actually from a TiVo Tarantula. Why? Well, it had the right aesthetic and it was compact. However, it prints like absolute garbage. It is so bad. It under extrudes, it dribbles, it sucks. So a lot of the choices here were for aesthetic reasons, to make an actual functional relic, I guess, from the game, rather than actually trying to make a good 3D printer. But yeah, that hot end is rubbish. I thought long and hard about control boards and ended up settling on an MKS Gen L version 1 from the JG Aurora A5. Some of you may remember I reviewed that machine back near the start of the year, I suppose. Unfortunately, that was when manufacturers were in the habit of sending out really early pre-production units to reviewers. So my JG Aurora A5 was absolute garbage after a while. It had 3D printed parts, it started failing, and it started doing, I think Devon ran into the same issue where motors were having intermittent connections and the whole machine would just judder and fail, and it ruined its own ultra base. So I decided to gut it and take the control board and LCD screen out of it for this project. In terms of choosing the actual design approach for the Vaultek Personal Fabricator, it was pretty clear that it had to be Cartesian. There's not really the right form factor for a Delta, but choosing the actual Cartesian approach was a bit of a challenge. So I actually went with a single lead screw on the Z and a supported Z rod. So there's only one lead screw, but it's better than cantilever. And the actual Y-axis and Z-axis has 8mm rods, but to keep things lighter and more compact, I actually went with 6mm rods for the X-axis, and that worked out quite well. But again, that limits the accessibility of this design, so I'm planning to make it all 8mm rods for a future version that won't be constrained by this box. The entire machine was designed in Fusion 360, and it was an absolute slog. It took a very long time to design. I'll be honest, guys, my approach for designing machines like this probably isn't the correct way, but I don't feel comfortable with joints in Fusion. I don't really like them. I find they're a little bit random in terms of when they work and when they don't work, and I don't like it when things explode. So I would have been having to make lots of rigid joints anyway. So what I did instead is just model bodies in bodies. And this is probably a controversial approach to modeling things because nothing actually moves unless you then make it a component to move it. But I found this was really good for referencing things to other things and making sure stuff had clearance. And I went through various iterations to get it right. So for example, this was the first version I tested, and I sort of hacked at it to try to fit things and try stuff. So it didn't change a huge amount. A lot of stuff was just small tweaking and moving where I wanted the actual Z-axis to sit. But it's all printed in one go, and it has this curve to fit the base of the Pip-Boy box correctly. So I actually made a custom profile in Slicer Prusa Edition to print this really quickly, because these are for prototyping, and then I did the final version in grey. So this is at a 0.3mm height, and I have a setting called 0.3 stupid fast, because it prints really fast with a low infill at 0.3, and this takes like 9 hours, maybe 8 or 9 hours, so overnight. That's a significant increase in productivity if I'm trying to prototype very quickly. So I would print overnight, get the parts, test it, form fit, change, print again. And I went through 4 versions of this. So a little bit more than my usual rule of 3, but hey, it's a 3D printer. It's got a lot of things going on. It's not just a simple design where you can get away with 3 tests. Unfortunately, the gray I went with for the final version is really cheap. I'm not going to name the brand because I don't recommend it, and it under extruded for some areas, which was really frustrating. After testing and testing with other cheap filament that worked but in different colors, the gray was pretty poor quality. So I actually ended up finding a use for my 3Doodler. The guys over at 3Doodler sent the Create Plus to me a few months ago, and I literally said I'm not going to review it, but if I find a use for it, I will show it on the channel. And I actually just loaded up some gray PLA that they sent with it, and I patched up the seam where it had under extruded, and it was actually really effective. It stitched it together, and I sanded it back, and you can't tell because it's hidden here just underneath, but it's where the rods are, so I mean that's got a lot of tension when I hammer them in because it's a tight fit. And it worked really well. So yeah, I mean, using a 3D pen to patch up 3D prints is a legitimate use case. I'm not really artistic. I'm not going to be doing 3D artwork with one, but I will be using it again to glue stuff together. And even for the holotape, which was a design on My Mini Factory, I'll link it in the description, which worked really well. I just used the 3D pen to sort of glue it together. And yeah, it actually stuck it together really nicely because it's PLA on PLA. So I can actually recommend that technique, and I'll be doing it again in future. To attach all the parts in place, I used M3 screws and M3 nuts because tapping into plastic, especially with an M3 thread, is a very bad idea. Essentially, the trick was to design it where I could have captive nuts but not need support material and print it as effectively as possible and as quickly as possible. So I use a combination of sacrificial bridging. So for example, where the stepper motor is here for the y-axis, there was a bridge, which is 0.3 millimeters thick, and that went across there. And I also made sure that the holes had a taper at the top of them, like a teardrop shape, if they're horizontal, because when you're doing holes in 3D printing on FDM, when it gets to the top, it starts to droop a bit and you don't get dimensional accuracy. And I also made sure there was enough clearance for the M3 hex nuts if I wanted to go sideways. So for example, this part here on the side where the rod goes in, that has to be really tight. So it's tight already, but then the M3 nuts go into the plastic and they get tightened to clamp it in place. All that sort of stuff was all done bit by bit. It took a very, very long time to get right, but I'm really happy with the result. And it meant that this entire part printed with no supports, like none. That was a pretty good achievement. I was also pretty happy with how I got the tolerance correct on the linear bearings for the Z-axis, because with 3D printing, it's not completely accurate. You have tolerance and you need clearance, but you don't want wobble in those bearings. You want them to be a press fit. So I actually designed a sort of area where the plastic could kind of give way a bit, almost like these little arms that had a bit of flex to them. And I was really happy with how that worked out. It meant I could push the bearings in, they were tight, but you didn't have to hammer them in or anything like that. And as I mentioned, the y-axis had lots of constraints on it because the box is so small. So I went with a very unusual belt path that sort of wraps around the stepper motor using idlers. So for the belt, they're driven around the stepper motor to get lots of teeth engagement, but then it goes back to the standard path that the y-axis can run in. But yeah, as long as you can guide the belt accurately, it doesn't really matter where the stepper motor is in the general scheme of things, as long as it's got enough tooth engagement. My issue here was that I used idlers from the Hooney H6. Some of you may remember that 3D printer. They are absolutely rubbish. If you tighten them up, they bind up and jam. So I had to use a combination of nylock nuts and the actual idlers to make sure they weren't crimped on, and if they're under pressure, they'd stop turning. But I also had to make sure that I used the nylock nuts to get tension onto the screws that were inserted into the 3D print. So yeah, I used parts that I had on hand. If I was to do it again, I would go buy some actual idlers that aren't complete rubbish, so I could actually tension them nice and properly. Something else I did that I'm not 100% happy with was the X-axis motor. It's not a standard NEMA 17. It's actually stubby, so it's got more than enough torque for the X-axis, but it mounts from the back forwards, and that means it's hard to tension properly. I did it for compact reasons, to make the machine nice and small and keep the weight down on the X-axis, but I would change that to a normal NEMA 17 for a production or proper open source version, because it's non-standard. It uses a different plug. That plug was giving me issues because it's doesn't hold very well. So that's why I had to have like this wire sort of at the back floating, because if I put any tension on it, it would pull loose. And then when a stepper motor comes loose, the drivers freak out and the whole thing shudders violently. So I'm not hugely happy with that, but it does keep with the compact aesthetic. And for the extruder mount, I use zip ties for the linear bearings. And honestly, I used to poo-poo this, but it seems to work great, and the original Prushas used to do it. So yeah, if you've got a decent mating surface, you can actually use zip ties to hold bearings in place for low load applications like this, which has very little load on it. And I was actually pretty happy with it, so I might do that again also in future. As I mentioned, the actual extruder is from a Tevo Tarantula, and the real issue with it is it's the style similar to the Creality ones, where the PTFE comes in and butts up against the nozzle, and if there's a gap, you have very poor extrusion control. But the issue is the tolerances inside the actual tube are poor as well. So I don't think it's possible to get good extrusion quality out of it. It's just there's too much melt zone and not enough tolerance in that melt zone to get a good control from a Bowden. And there's no cooling fan either, so part quality, especially stringing, will be an issue. So if I was to design this again, or in an open frame, I would definitely get some sort of cooling fan. And the actual Bowden itself, I'm not sure what it's from. I think it might have been the Hooney. Either way, it's the bog standard spring-loaded one with the brass gear. And the Bowden means it's very compact. I mean, that you could not have room for a a direct drive extruder here. There's no space for it. The machine has limit switches, obviously, to home the X, Y, and Z axes. And I actually use these really neat new old stock ones, which I've had on hand for a while. These are Honeywell switches, and they're the old sort of epoxy potted ones. And they've got a really satisfying clicking action, really nice, really robust. They're 51 SM1-T. And I don't know if they're still made, but I got like a box of them for really cheap a few years ago. I really wanted to go with that old school aesthetic, which is sort of retro futuristic, the whole sort of Fallout vibe. And they work really well, except they don't have a lever, so I had to make sure everything lined up perfectly so they would hit. But they're lovely, lovely switches. The keen eye among you will notice that there is no bed leveling at all on this machine, and that was done to keep the thing compact, and interestingly enough, it doesn't actually need it. This bed is so small, and the machine is actually rigid enough that it gets a decent layer height across the whole print area, surprisingly enough. And that print area actually used Easy Peelsy, which I reviewed not too long ago, video here, if you want to go check it out. It's a magnetic removable print surface, and it works really well. So this is the print I did in the video. I haven't taken it off yet, and it's just sort of like that. It works really well, and you just pop it back in. Getting the mechanics done correctly was one challenge, and I did a lot of that outside of the box. But then the final challenge was the wiring and mounting the LCD into the Pip-Boy. Now, if you're a fan of keeping these promotional items unravaged, then look away. But getting this screen mounted into the Pip-Boy was a nightmare. It's originally designed to fit like a smartphone, but they're very thin. Modern smartphones, you're not going to find one over 10 millimeters thick, whereas this board with a connector goes down about that far, so it goes way down and even starts interacting with like where the sort of armband Velcro is. And quite fairly, a lot of you guys commented in the video that I was wearing this on the wrong arm, and that is true. I'm left-handed, so I can't have this on my dominant hand like this, operate a camera with it, and then do, like, I can't. My brain won't let me. I have to have it on this arm, which meant it had to be backwards, but it meant I could actually use it. So, yeah, Vault-Tec didn't accommodate for left-handed Vault Dwellers very well, unfortunately. As I mentioned, I did a custom splash screen. I designed it in Illustrator using the Vault-Tec logo, and I converted it to a bitmap and then used a bit of software to make it into a binary file that the screen and firmware could understand, and I will be doing a short tutorial on that in future. For a bit of fun, I thought it'd be cool to have the filament come out of an actual ammo box, so I have this 50 cal ammo box that I got from a local disposal store. Hopefully I won't get party van for having it, but basically I did try to make sure that they could see that it's a non-repairable one. This has clearly been sent to a disposals, but it's a really cool box, and I just put the filament in here and ran it into the back of the Bowden. And I'll probably do something with this in future. I want to do a project with it. It's too small for a printer, but maybe a small computer? I don't know. It's really neat though. Obviously a custom build like this with randomly sized timing pulleys and lead screws and stuff needed custom steps per millimeter. I couldn't use the default in the JG Aurora A5 firmware, but something that was really frustrating is I couldn't change it using in the default firmware. I would go into Repetier and change the numbers, and it would like send it and then not remember it. I had no idea what was going on. I ended up using community firmware for the A5, and then it remembered it. So I don't know what's going on, what JJ Aurora did to the firmware, because it's just Marlin, but it didn't work. So I went and did that, changed it. It's very easy to calculate your own correct steps per millimeter using a simple formula. I'll do a video on it as well. But basically I did that, and it prints actually pretty accurately now. Everything's moving the correct amount with the custom firmware for the A5, but just modified slightly for my build. I used IdeaMaker to slice G-code for the printer. I made a custom profile, made it sure it had the correct build volume, and as I said, the Bowden definitely could be better, so I had to bump up extrusion rates for the top infill. But overall, didn't have to change too much, and it does a little wipe as well, which is quite nice. That's default usually in IdeaMaker. It helps prime the nozzle, and it prints quite fast, actually. It prints quite quickly, and I was really just quite happy with how the unit chugged along. Something many of you would have noticed is the wiring travesty that is in this machine. The thing is, there is so little room to get all of this stuff working that there is literal millimeters, maybe just 1 millimeter separating the wires from the print bed. Wires run underneath, there's zip ties, stuff hidden, but there is such little room to play with that this control board is just right there. I didn't want to cut into the side here because that would have just been wrecking this box too much, but it's mounted on the side and it clears just. But man, is it tight. It was so difficult to get the clearances working correctly, but we got there in the end. I actually even sourced old school LEDs made in the USSR, red ones and green ones, which would have been really rare back then, but they were just too dim to use in the project. I mean, to be fair, they're like the really early LEDs, which are good for indicator lights in dark rooms, but for this printer, especially when you're doing cinematic stuff with lights, you couldn't see it. Like the little red one on the control board overpowered everything, and it's a tiny surface mount LED. So I'll use them for something else, but they didn't make it into this project, unfortunately. So where do we go from here? Well, this thing was tons of fun to build, but unfortunately I won't be releasing the files for it, mostly because they're not useful to anyone else, because they're made specifically for this box, and there is tons of custom hardware and sacrifices that had to be made to make this thing fit. However, what I'm going to be doing is taking this design, because I'm really happy with the single print base. I really like how that came out, and the actual design overall is quite stable. So I'm going to be taking this and modifying it to make an open source design that you guys can print at home. So a few things I want to change. Obviously the print volume is way too small. I want to make it at least 120 by 120 by 120 millimeters. I think that's a reasonable size for something that's still quite compact. I want to change the linear rods to all be 8 millimeters, so that's easier for to make it standard and consistency. You can just buy some longer rods and put them in. Also, by the way, cutting hardened rods is a real pain. You need to use an angle grinder. You might want to try to order them cut to size or something, but basically I'll make it with using all 8 millimeter rods. I do like how these tensioners came out. That keeps the parts rigid without relying on the rods themselves. So they'll stay in the design. They're just M6 threaded rod. And I think what I'll also be doing, I'll be keeping the easy peelsy print surface. I really like that, but I'll be adding some sort of bed leveling, because as you get a bit bigger, I think it's important to have some degree of ability to change that bed and make it work. I do like how the Z axis limit switch adjustment works though. I'll keep that. Obviously there won't be a case to constrain it. This machine actually works without the case. The case is just purely cosmetic. It's bolted to the bottom with 4 M3 bolts, M3 screws, like that's all that holds it in place, but it works completely separate to the case. So I will be making the next version without a case, obviously, and I'll keep the overall design, like the single lead screw axis, but I'll change the functionality of the actual interface. I think we'll just go to a standard LCD with click wheel and a more accessible control board, and I'll change the extruder and the hot end, because the one I've got is terrible. So maybe an E3D light, something along those lines, with a cooling fan to give you guys much better print quality. Still unheated. I think the print bed being unheated means you can use a low cost external 12 volt power adapter, which is also nice and safe, but I don't really think you need to go much more ridiculous than that. It's going to be a accessible, low cost open source printer. So low part count and easy to assemble is the goal for this design moving forwards. But before I finish up this video, guys, I just want to say a huge shout out to my Patreon supporters. You guys are incredible. I said I was taking a break through October, and I fully expected many of you to drop off because I said I wasn't going to be too active, but actually the opposite happened. Many of you jumped on board to support me and the channel and my actual words of saying I want to put more into myself to bring you guys better content. So thank you so much for that. I cannot express what it means to be able to put time into this, to then now use what I've learned here to bring you new, fresh content, because I've got enough stuff that I've done with this to bring forwards tons of videos, more videos I could even do, which is amazing. So thank you guys. And as a big thank you, this video is going out to my Patreon supporters a week before everyone else sees it. So if you see comments in the description, that was from my amazing Patreon supporters. So thank you guys. I really do appreciate it. And if you enjoyed this video and you enjoyed seeing this and you want to see more, you want to see small details and tutorials and guides around 3D printing, then please consider subscribing, because on Maker's Muse is my aim to empower your creativity through technology. And this is, I wouldn't have been able to do this just a few years ago. Be able to put all this time and effort and design skill into making this little compact machine. I want to empower you guys to be able to do the same if you wish, or in anything that interests you. So thanks for watching, guys. My name is Angus, and I look forward to seeing you again very shortly here on Maker's Muse. Catch you later. Bye.